Today we are going to learn how to factor and solve when it appears that we cannot factor. So if I gave you this polynomial, x to the third plus 2x squared minus 5x minus 6, if you split this down the middle and tried to factor by grouping, the two sets of parentheses would not match. You can't factor this by grouping, it doesn't work. So we have to find some different method for factoring. And we're going to be using the fundamental theorem of algebra, Descartes' rule of signs, and the rational zero theorem. Those terms all sound scary, but they're really not that bad. And you don't have to memorize the names, you just have to know the process for how to do this. So our first example, I basically lined it up step by step, leading you through exactly what we're doing each step of the way. Step 1, the fundamental theorem of algebra tells us that the degree, or the largest exponent, is going to tell us the number of solutions for that problem. So in this particular polynomial, how many solutions are there going to be? 3 solutions. In step 2, we're going to determine the type of solutions we're going to have. So from step 1, we know there's going to be a total of 3 solutions. The positive solutions come from Descartes' rule of signs. Descartes' rule of signs says that the number of sign changes in the polynomial gives you the number of positive solutions. So what do I mean by sign changes? This first term is positive. Do you all agree that this first term is positive? Okay. The second term is still positive. Right here, we have a sign change. The polynomial changes from positive terms to negative terms. The next term is still negative. So we haven't changed again, it has stayed negative. So there is one sign change from positive to negative in this polynomial. That means there's going to be one positive solution. If there's one positive solution, and there's 3 solutions total, how many negative solutions would there then be? 2. Now, here's the one kind of crazy thing. It says, or less by 2. There's the chance of imaginary solutions, and if we happened to have imaginary solutions, that would take 2 of the solutions out of the mix. So if we have 2 negative solutions, there's also the chance that there are no negative solutions. There could be 2 or 0. Whenever there's an even number of possible solutions, it's even or less by 2. So next we're going to look at what are the possible solutions. Technically, you're supposed to take the constant term, which in this case is 6, divided by the leading coefficient, which in this case is 1. But I'll give you a hint. I'm always going to give you polynomials with a leading coefficient of 1. So really, the possible solutions are going to come from whatever our constant term is. So we need to look at ways to get 6, factors of 6. How can we multiply to get 6? 1 times 6, 2 times 3. Our possible solutions are 1, either positive 1 or negative 1, positive 2 or negative 2, positive 3 or negative 3, positive 6 or negative 6. We need to test to see which of these are solutions. We could test positive 1 and then test negative 1 and then test positive 2 and then test negative 2. But right here, it says that we have a chance of 0 negative solutions. So we could test negative 1, negative 2, negative 3, and negative 6 and have it not work. We are guaranteed to have one positive solution. So I am going to test the positives. And I'm going to write here, test positives. Because right up here, I am guaranteed to have one positive solutions. Do you remember synthetic division? We are going to test our solutions using synthetic division. So down here, let's recopy this function. 0 equals x cubed plus 2x squared minus 5x minus 6. We need to test these possible positive solutions using synthetic division. If I test the value 1, do you remember what I write inside the synthetic division? 1, 2, negative 5, and negative 6. The coefficients. 1, 2, negative 5, negative 6. Quick review of synthetic division. Drop the first number down. We multiply the number outside the synthetic division with the number on the bottom. 1 times 1 is 1. That gets written up inside the bracket. And then we add. 2 plus 1 is 3. 1 times 3 is 3. We add. Negative 5 plus 3 is negative 2. 1 times negative 2 is negative 2. And then we add. Okay. We want this to be 0. If it is not 0, then 1 is not a solution. We can cross that solution off and say 1 doesn't work. Now we need to try the next number. So now I'm going to try 2. 1, 2, negative 5, negative 6. Drop the 1. 2 times 1 is 2. Add them. 2 times 4 is 8. Add them. 2 times 3 is 6. And we got 0. Now, is it possible that you're going to have to do synthetic division 2 or 3 or 4 times to find a solution? Yes, that is definitely possible. So we got 0. That means that 2 is a solution. So yay, we found one of our solutions. What next? We have to rewrite this and continue factoring. So we have 0 equals, if 2 is a solution, that means x minus 2 is in the factored form. Because remember, when you're solving, what number minus 2 gives you 0? Positive 2. So if 2 is your solution, x minus 2 is in your polynomial. The second set of parentheses comes from the result of our synthetic division. So I'll color that purple so we can see that those are connected. So that would be x squared plus 4x plus 3. How do I know it's x squared? We started with x to the third. We just took one of those x's out, so now we have x squared left. So this is going to be our x squared term, that'll be our x term, and the 3 will be the number at the end. Then it says, finish factoring. So factor this trinomial. We need 2 numbers that multiply to give us 3 and add up to 4. 1 and 3. So we have 0 equals x minus 2, x plus 1, x plus 3. And that means that our solutions are positive 2, which we already knew from up here, negative 1, and negative 3. We were supposed to have 3 solutions, 1 positive, 2 negative. We have that. We were also supposed to have, look at our potential solutions, 1, 2, 3, or 6. Notice our solutions are within those possibilities. Your first step is going to be to determine the number of solutions, the type of solutions, and what the possible solutions are. So that's like part 1. So our degree, the largest exponent, tells us the number of possible solutions. There's going to be 3 possible solutions. Of those solutions, we are going to have positive solutions and negative solutions. The positive solutions are determined by the number of sign changes. How many sign changes do you think you see in there? Because there are 2 sign changes, we have the potential for 2 positive solutions and 1 negative solution. The one kicker about Descartes' rule of signs is that it says that number or less by 2. So anytime you have an even possibility, you also have the possibility of no positive solutions. So when we test with synthetic division, should we test the positives or should we test the negatives? We're going to test the negatives because we're guaranteed a negative solution. Now, what are the possible solutions? The possible solutions come from the number 20. Whatever number is at the end, that's where our possible solutions come from. How can we multiply to get 20?
1 times 20, 2 times 10, 4 times 5, 10 times 11. Okay.
So there's 6 possible negative solutions. -1, -2, -4, -5, -10, -20. Hopefully we find it before we get to 20, because I feel like sticking -20 into synthetic division might be a little bit messy. All right, let's test these. Test -1 using synthetic division. The numbers in the synthetic division are 1, -8, 11, and 20. So we tested -1 and we got 0 on the first try. What does that mean? That means -1 is a solution. If -1 is a solution, then x plus 1 is in our factored form. And the result of the synthetic division gives us the trinomial that's left over when we pull that x plus 1 out. Once we have this partially factored form, we need to figure out 2 numbers that multiply to give us 20 that add up to -9. -4 and -5. X minus 4, x minus 5. And that means our solutions are -1, which we already knew from up here, and +4 and +5. Okay, I feel like there's 3 main pieces to this. The first piece is over here in purple. Figure out how many solutions, how many positive, how many negative, what are the possible solutions. Part 2 is the testing process where you test those solutions and find your first solution. And then part 3 is factoring and solving to get all of your final solutions. Okay, I want you to try number 2. Get it started on your own. See if you can do this on your own. Once you figure out the number of solutions, type of positive, type of negative, the possible solutions, and test them, sometimes frustratingly so, we found that 4 was a solution. That means x minus 4 is in the factored polynomial. And then this 1, 5, and 6 makes up the leftover trinomial, x squared plus 5x plus 6. And we need to continue factoring from there. So we're looking for 2 numbers that multiply to give us 6 and add up to 5. 2 and 3. So we have x minus 4, x plus 2, x plus 3. And that means our solutions are +4, -2, and -3.